Hey everyone, and welcome to day 3 of Advent of Witchcraft. First 2 days was a bit of setup, had to show how to get started. Yesterday we found a nice spot where we want to start doing some creative stuff. So yeah, today I want to show you a bit more practical stuff you can do. So first of all, what I want to point out is that actually if you look at the Witchcraft code base, there's a gallery namespace group or directory with a bunch of things which are basically sort of like ready-made, creative things, creations that you can try out to sort of see, the kind of things that you can do with Witchcraft, and it hopefully kind of show off some of the different APIs that are in there. And I think sort of our flagship object is this big chicken. So this uses the shapes API. So we have shapes namespace, which contains things like box, ball, line, tube, torus, and so you can sort of combine those. The result is just a block set, which you can then pass to set blocks, which we showed yesterday as well, or the first day. So for instance, here I say that I want a box which is 5 in length, 7 in the other direction, 5 high, made out of white wool. And so then, you get something back like this. And similar to what I was doing earlier, just combine them all, put them all in a certain location. And so what that looks like, for instance, is that I should be able to do something like this. Well, once I evaluate this namespace, at least. And here we have our chicken. Ain't that a good chicken? Has its feet in the snow a little, but I don't know. I think that's a cool chicken. I also went ahead and added this Mega Chop 9000 creation to the gallery. So you see I no longer have any tools in my inventory, but let's rectify that. So we have the Mega Chop name, which is make it really just the string Mega Chop 9000, but then interspersed with these things which tell Minecraft that we want to use certain colors. Is this guy gonna punch me? Try me. So create Mega Chop, there you go. Creates the actual axe with the right name and lore. So this returns an item stack with a bunch of metadata, including that display name. And then for all convenience, I added a give to player function, so I can give this to myself. Once I evaluate this namespace. Right. Fill. So another thing is I added this fill API. Since this is kind of fill or flood, it's usually called, I guess, in graphics programs. It's just this neighbors and fill functions. I also showed them, I think, yesterday. And then I added a couple generated some convenience functions, because you usually want to either like go in all directions or work in a specific plane or work only in one direction. So you can sort of pick which axes you wanna fill across. In this case, it's fill x z, no x y. X, yes, X, Y, Z, just all direction, and then we don't need this one. Right, so can I give myself a Mega Chop now? Yeah, I think I do. So, for some reason, it does that. Yeah, so there's our Mega Chop. And now I need to register the event listener, and then as I showed yesterday, I'm sinking in the snow. Hello. Okay, let me just does that it does that Minecraft is a little too adamant on stealing focus. I'll just give myself flying to get out of here, if I may. All right. Grab a random tree, show that now our mega chop does its work. Whole trunk is gone, and then the rest of the tree, the leaves should disappear soon too. Now, this requires some event handlers, and so I set those up now with the register listener. But so when I restart the server, that's going to be gone. These only exist in memory right now. And so that's the other thing I wanted to show today, is how to sort of, these Clojure-based mods, so to say. If you have, your own namespace, you want to register some stuff at startup, you do that in witchcraft.eden. So this is the directory where my server is running. So paper.jar is the server. There's the server properties where a bunch of stuff is configured for paper or Minecraft server. And then there's plugins where we have our Witchcraft plugin. And so the first time you run that, you're going to see it creates two files. It creates depths.eden, which Clojure people should be familiar with. So you see that we put Witchcraft on the class path. We just always pull the latest version. You can pin that to a specific version if you like, but we do it this way so that when I release a new version of Witchcraft, I don't need to release a new version of the plugin every single time. Whenever people start using the plugin, they get the latest version. And then nrepl, cider nrepl, so that we can run an nrepl server and connect to that. And then there's also witchcraft.eden, where you can configure your nrepl server. So I have some middleware I inject there, but maybe that's not the same for you. You can change that. Some stuff about dependencies. And then here, so in this case, what I could, for instance, say, if I always want to have this mega chop available, I could say, well, at startup, load this namespace, and then run this register listener function. So you see there's a couple things here that are important for Witchcraft to work properly, in this case on paper. Some initialization that needs to happen, so those are there, you should leave those there, but then yeah, you can add extra stuff here. And so also, that's demonstrated here. So if I say, pads my mods, and then I create my mods chop thing, right? And then I can just, put whatever code I want here, and basically in my Witchcraft Eden, don't just say, okay, require chop thing, and that's my Clojure mod. And whatever needs to happen, I just put here at the top level, register event handlers, stuff like that. So that's fun and that's good to know about. Now today I want to decorate those trees. I want to hang a bunch of lanterns from them. That seemed like fun, kind of seasonal thing. So we're going to stick to the same pattern, and I already did a little bit of prep for that. So in this case, it's not going to be the Mega Chop 9000, it's going to be the Decorator 9000. So this is its name. Got a similar function. In this case, I'll make it a stone axe. Name it Decorator 9000 with the lore in italic Twinkle Twinkle. So let's add that to my inventory. All right, so there's our decorator. Now the fun starts. So I had an event listener, and here I want to do this step by step this time to show a little bit more what this does exactly. So when you call listen, the first key you give it is an event name. So this is based on the bucket event name. If you want to know all the events that we know about, I think there's somewhere here, events, you can find that out, right? So these are all the events that we found. We basically scanned this at startup. So no matter which events your specific server supports, we should find all of them. And then the second key here is just a key that you choose. And so this is similar to for instance, the watch function in Clojure core. When you want to watch an atom, you give it a key. And then later on, when you call watch again with a different key or add watch with a different key, it's going to replace the previous one. And so the idea is the same here. So this is intended for REPL usage. You can keep calling this elisten with a different implementation. And if it's the same event and the same key, it's going to replace the previous one. You also need that key if you want to unlisten at some point. Then you also say, okay, well, this is the event and this is the key, in case you would want that. Now, what is passed here, and this is one of the few places. So when I first started out, doing Minecraft stuff with Clojure, I used Clojure's bean function a lot, which is just a way of sort of taking a Java object and giving you something that is more like a Clojure map. Now it's not very efficient, and it's it has some downsides, and most of the Witchcraft API no longer really uses bean. But in this case, we still use bean. Basically, what you get here passed into your callback is a beanified version of the event object. So Bucket API, Bucket events, they're all specific objects. Each object has different fields, different functions. And so we just, beanify that so that you can pretend that it's a map. You can destructure it depending on what event you have. You'll find some keys in there. And so maybe let's actually, for starters, so this is a good way to start when you want to start figuring this stuff out. So yeah, let me just, at this point, I'm going to get every interaction event. So whenever I interact with a block, they should get called. So at this point, E should be defined, right? And so you can see I have a bunch of stuff in here: block face, event name, display redirection event. We knew that. The item you're interacting with. There should be a clicked block. And you see that for some objects, we register like custom printers so that they print out a little nicer as tagged literals. These are not readables. I don't think we have actual readers for these things yet, so you can't put this in your source. But at least it prints more nicely. Right, so that's the event. Now in this case, we mainly care about the clicked block. So, well, we care about a couple of different things actually. We first want to know, is the item in the hand of the player a Decorator 9000? Before we did that, if you go to the Mega Chop implementation, here I do this by checking the display name of the item. So I'm going to do actually the same here. Display name of the item in hand should equal to Decorator 9000 name. Right, so if I just print this for now, open my REPL here. So now that's false, but if I switch to the Decorator, it's true. Okay, so that's cool. So when there's a click block, because not every interaction I think has a click block, and we do rely on those, and we're using the Decorator 9000, then we want some specific logic. In particular, actually, we're gonna look at the material name of the click block, and that should equal, in this case it's gonna be spruce lock, because we just have a bunch of spruce trees around here. So I guess I'm just gonna, and for the chopper I looked for anything that ended in lock, so basically any tree type. Will just be concrete here, say okay, this one, the Decorator, works with spruce. So if it's a spruce lock, then the fun starts. So yes, Right, so here it does nothing, but then if we go to a spruce and we click on that, yes, there we are. So we're gonna use the fill algorithm again, fill XYZ all directions from the click block, and pass it a custom predicate. Actually, we can even make it easier for ourselves. We don't. So the default predicate just keeps searching until it hits air. But also the default fill function only looks in a single horizontal plane. Now in this case, if we just assume that you click on the bottom one, then if we say that we can look up but not down, so this, if we say -101, it would look down and up. Y is the up-down axis. I just say 0, 1, that should mean that it only looks up. So let's do a similar thing here. And did that do anything? Oh. It did. So it found 112 blocks. And as you can see, some of them are, well, yeah, I found some snow too, I guess, in the current plane, probably quite a bit actually. But mostly it's spruce log and spruce leaves. So what we'll do then is filter out the leaf. So what I want to do, my strategy here is going to be that we take all the leaf blocks, and then from there we filter them out to only include the leaf blocks that have an air block directly below it. And then we'll randomly take a bunch of those and hang a lantern there beneath those leaves. So let's filter out the leaves, right? So in this case, I'll use material name on the block. This is going to return me a keyword. So this should be spruce leaves. So click on that. Right now, everything we have is spruce leaves. And always good to sort of do a sensibility check. 62 for a tree. I mean, this one might be touching another tree, and so our fill algorithm might have found 2 trees. Not sure. I guess if that's the case, yeah, you know, then that's fine. Not gonna worry about that right now. So now that we have that, let's introduce a, actually, can I, what does this look like if you do a thread last? That looks a little weird, but if we do this, it's not so bad. And it's already a little bit more readable. Let's call this leaves. And now I guess we want to filter those once more. In particular, so we're gonna, in this case, when you want to inspect sort of the state of the world, you tend to use block, which you give it some location-like thing, and Witchcraft is very forgiving there. You know, you can give it a vector, you can give it a map, you can give it a bucket location object. I think you can even just give it another block. It'll figure that out. So in this case, we want to go one lower. So we'll add to the location of the block -1 on the y-axis, which is sort of up down. So now we get a block back, and we want the material name of that block. And so in this case, I think a thread first is probably going to make this a little nicer. Yeah. Right, so we have the block in our set of leaves, take its location, go one down, get the block there, check its material, and that material needs to equal air. So that is actually, I think, our predicate and our filtering, our set. So yeah, still 62, which is slightly odd because you would think that it would reduce the amount. Oh, I didn't click on anything. Right. 44. Okay. So let's actually just continue on the REPL now to sort of see what happens. So say that I, to get a random selection of these, let's say that I shuffle them and then take 10. I don't know. Right. So now we have these spruce leaves. Maybe actually here, how about it? Because we no longer care about the leaves, we really just care about the blocks below them. So let's already get the actual air blocks and then filter them. So we want the material name of the block where we ended up to be air. All right, so now we should have, what was it, 44 air blocks. Okay, so gonna just shuffle those. And in this case, we got maps back. That's what block gives you. There's a, is it get block? Yeah, so if you really want the bucket block object, you have get block. But if you just say block, you get a map back, which is kind of convenient, which then means that we should be able to say, so is it, yeah, lantern, right? So, okay, how about I just say here, from those 10 random entries, assoc material lantern, and then we put those in the world. Actually, oh yeah, we already undid our chicken. Wanted to make sure that there was no more stuff on our undo stack that we still wanted to undo. Yeah, so I'm just gonna call set block on these. That set blocks, that should work. And look at that, our tree now has some random lanterns. So actually this tree, and as we thought, it kind of extended to the next tree over. But that's cool. I mean, the alternative, I guess, would be to sort of first, use a fill to just find the trunk, and then from there find leaves. But this is already cool. So let's actually put this into, yeah. And so this case we had 44. I've taken 10 of those. I think, yeah, maybe like 1 in 4 or 1 of 5 is maybe like a good amount. Let me undo this now. So can just continue with this thread last. We shuffle. Yeah, and now let me stick that as in a local use a let air blocks, and then we take math round count air blocks divided by actually I guess I don't need to, I can just use, what is it, quad, right? Quad is like an integer division. Define numerator, yeah, quotient. except that this probably can return a ratio, which might be a problem. Quad 5.2. No. This returns an integer. So yeah, let's say 1 in 5 maybe. Don't want to go too overboard. I guess it's better if it does fewer of them, because then we can just like chop multiple times. So let's even say 1 in 6. Right, so 1 in 6 of our air blocks, and then we do this. Clean up a little here. Okay, I think that's our decorator. Let's try it on another tree. Whoa, yeah, my flying speed, I guess, is still high from the first episode. Yeah, so in this case, it's not. Some of these spruces have sort of these different levels, which is kind of. Oh, that's suddenly a lot. But so it puts them. Oh yeah, and there's a couple here because they're neighboring. I mean, that's random for you, huh? Like you don't really know. But I feel like my fill. I mean, is it just kind of randomly that we're not getting any landers up there, or is there something funny happening with the fill? And is that too many? Let's undo one. But yeah, so let's go around and make this a little festive. No? Come on, buddy. Not getting exceptions, are we? Oh, we are. Fill did not terminate. So yeah, I added a little bit of safeguards in the fill algorithm, because it's very easy to end up with like, yeah, a fill that just doesn't terminate. Oh, is it because it's snowing now that like it's still an air block, right? Where did we go wrong? Yeah, maybe. How are we defining our fill? Yeah, just with the default predicate. Let's actually define a custom predicate here, because we really want to be more specific, I guess. And I guess we can just do it this way. So it has to be a spruce log or spruce leaves, which is the material name of the block that the fill algorithm is processing. And in that case, this doesn't really matter. We can just, go XYZ. Okay, how's that? Let's also keep the REPL there so we see if there's. Okay, now it does something. Yeah, I guess, and yeah, because all these trees are like almost touching, or like, thing is, if they're diagonally touching, it's probably enough to like continue the flood algorithm or fill algorithm. But yeah, it's already a lot. I should maybe lower the numbers slightly, but I like it. I think this really helps to. And then with the snow, I mean, it's only a first step, but yeah, we can use our decorator to our heart's content. Let's make this a little lower. Now, boom, and boom. All right, and with that, we're already at half an hour again, so I really should wrap up. But I hope that was interesting and fun, and I should see you all tomorrow. Ciao.